Welcome to my channel. Here I will discuss about alternative series test. In this series test explains summation AIBA series. This series is a alternative series. This series is an alternative series. Is alternative series that means alternate the signs and decreasing the absolute value that tends to 0. Then it will be converges. Alternative series converges, that terms will be decreasing, that terms absolute value will be decreasing and tends to 0. Then we can say such alternative series will be converges. The error made in approximating the alternative series summation I equal to 1 to infinity by its nth partial sum Sn equal to summation I equal to 1 to n ai is not greater than an plus 1. Above this theorem, this test will explain every alternative series is converges and its partial sum is Sn equal to summation I equal to 1 to n ai. This is the partial sum of our alternative series. Okay. Here I will explain one problem. Estimate the sum of the infinite series. One minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, etc. So we can take AI. Nth term is minus 1 power I plus 1 by I. So modulus of AI is 1 by I. And AI plus 1 is 1 by I plus 1. That 1 by I is greater than 1 by I plus 1. And so decreasing. This series is decreasing. AI is 1 by I, AI plus 1 is 1 by I plus 1 modulus. So we can say this terms of our infinite series is decreasing. Terms of this series is decreasing. And 1 by I limit I tends to infinity equal to 0. So three conditions are satisfied. Given series is alternative series. Therefore, summation minus I minus 1 I plus 1 by I converges. Okay. Let S be sum. We need to find the sum of infinite series. So S be sum. Sum of the given alternative series summation minus 1 power I plus 1 by I equal to 1 to infinity. Okay. So we can write modulus summation I equal to 1 to SB sum of the infinite series means S summation minus 1 I plus 1 by I converges to S. Okay, so we can write I equal to 1 to infinity minus 1 power I plus 1 by I minus S. That is equal to summation I equal to 1 to infinity minus 1 power I plus 1 by I minus summation I equal to 1 to n minus 1 power I plus 1 by I. That is equal to, I will write clearly. So we take S be the sum of given infinite series. So we can write series minus S summation AI minus S. That is equal to summation I equal to 1 to infinity minus 1 power I plus 1 by I minus summation I equal to 1 to n minus 1 power I plus 1 by I. So this can be written as, so up to n deleting in this series. So we get I equal to n plus 1 to infinity minus 1 power I plus 1 by I. So this is always less than 1 by I plus 1. This sum is always less than a I plus 1th term. So n plus 1th term. Okay. So we can write it is less than 1 by n plus 1. 1 by n plus 1 is always less than or equal to 1 by 10. So we can write so that means modulus AI equal to 1 to infinity. AI means minus 1 power I plus 1 by I minus summation I equal to 1 to n minus 1 power I plus 1 by I. That is equal to summation modulus minus 1 power I plus 1 by I equal to n plus 1 to infinity. So this series can be written as modulus sum minus 1 power n plus 2 by n plus 1 plus minus 1 power n plus 3 by n plus 2 plus etc. So this term is always less than the bigger term 1 by n plus 1. So 1 by n plus 1. Okay. This 1 by n plus 1 is 1 by n plus 1 is less than or equal to 1 by 10. So given that 1 by n plus 1 is less than or equal to 1 by 10. Error of magnitude no more than not more than 0.1. So error of magnitude is 1 by n plus 1, that is less than or equal to 1 by 10. So n plus 1 is greater than or equal to 10. So this implies n greater than or equal to 9. So we can take the error magnitude less than or equal to 1 by 10 is S9. So we can calculate the sum I equal to 1 to 9 minus 1 power I plus 1 by I. That is equal to 1, I equal to 1, we get 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus 1 by 7 minus 1 by 8 plus 1 by 9. That is equal to, we calculate the sum, we get 0.7456. This is the error magnitude, not more than 0.1. So I will explain once more. Given that estimate sum of 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 infinite alternative series with the error approximation not more than 0.1. So we take the alternative series that can be written as minus 1 power I plus 1 by I equal to 1 to infinity. This is an alternative series. Positive and negative sign alternatively came. Second one is C's are decreasing and third is 10 to 0. So this is alternative series. So this series is converges. Let me take SB sum of given series. So we can write the series I equal to 1 to infinity AI minus summation I equal to 1 to n AI. SB, the sum means our series converges to S. That SB, the sum of the finite terms sum. So we can write down summation I equal to 1 to infinity AI and it's a partial sum equal to summation minus 1 to I plus 1 by I minus summation I equal to 1 to n minus 1 power I plus 1 by I. So we get this is less than 1 by n plus 1. So given that error is less than 1 by 10, so we can write 1 by n plus 1 is less than 1 by 10. So n plus 1 is greater than or equal to 10, n is greater than or equal to 9. So we can approximate the magnitude of the given series. Error magnitude of given series less than zero point 0.7 is S9. That S9 is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus 1 by 7 minus 1 by 8 up to 1 by 9. So this sum is you calculated by calculator, you got 0.7456. This is the error of magnitude not more than